Bravo engine running.
Absolute genius.
Get this.
Welcome.
This is the show where we bring you
Science.
What that essentially means is
discoveries,
Advances.
questions,
Research.
technology.
Unbelievable.
Without further ado,
This is The Naked Scientists. Hello, welcome to The Naked Scientists podcast. This is the programme that brings you the biggest breakthroughs and talks to the major movers and shakers in the worlds of science, technology and medicine with me, Chris Smith. And coming up, former UK Prime Minister David Cameron calls for screening for prostate cancer following his diagnosis, but is it worth knowing you've got this disease? Also, scientists say DNA and protein building blocks found in the asteroid Bennu could help us to understand the origins of life here on Earth, and researchers discover where cats were first domesticated and when, and it's all much more recent than we first thought. First this week, the former UK Prime Minister David Cameron has disclosed that he has received treatment for prostate cancer, adding that he had a prostate-specific antigen, or PSA test, which is what revealed his diagnosis. Off the back of that, he's now calling for a screening programme for the disease. But, as Addenbrooke's Hospital consultant urologist and international authority on prostate cancer, Vincent Yarnapragasam explains, screening for prostate cancer is not straightforward. For a start, nearly 100% of men over the age of 80 will actually have the disease, but only a small fraction of them will die because of it. Picking up everyone with prostate cancer will therefore label massive numbers of men as cancer victims, with predictable impacts on mental health and well-being, as well as inevitably leading to overtreatment and some unnecessary side effects of treatment. It's a very difficult quandary. But are there, I asked him, any giveaway symptoms that might help to point to a problem that does need treating?
The short answer is no. There is really no symptoms of prostate cancer that someone could present with, unless it is a very advanced and metastatic, and therefore symptoms that arise are those which due to cancer spread, for example, bone pain. But certainly at the stage where prostate cancer is in the prostate, there are no symptoms which are specific to prostate cancer. Of course, men get urinary symptoms as they age, but that is not a sign of prostate cancer. And most important message, I would say, is the absence of urinary symptoms does not mean there is no prostate cancer.
So what can we do to find it? Is there a test that a person can have that gives them a directional cue as to whether or not they might be at risk?
Well, obviously, there are certain factors in family history and inherited genes which can raise the likelihood of prostate cancer, but that really is a minority of cases. For the vast majority of men, there are no risk factors or things apart from being male and aging that would suggest that you should go and look for prostate cancer. If you were looking to see if there might be prostate cancer, then obviously we do have the PSA or prostate-specific antigen test, which is widely available, and that can give an indication. It is, however, not a perfect test and on its own can't diagnose or exclude prostate cancer, and it's all about whether that test is at a level which would suggest we should investigate further. That would mean being referred to the hospital to get what's known as an MRI scan, and then following that, possibly a biopsy for the prostate.
PSA test then, can we not use that as a screening test? Is it not specific for prostate cancer? Can other things affect that then?
Certainly, PSA can be affected by urine infections. It can be affected by the size of the prostate, for example. So it's not a perfect test, but it is certainly one of the best blood-based biomarkers for any cancer. But it is not a simple matter of just saying, let's do screening, because you may find many prostate cancers which will never actually cause any harm. The problem is that once you detect it, that gives a label to a person as having a cancer. That causes anxiety, and that can lead to significant overtreatment. Investigation for something which may never cause trouble is what we call over-investigation. And really, the problem is that sometimes detecting an early prostate cancer may cause actually more harm than that prostate cancer might ever go on to do.
It's a real quandary, isn't it? Because I was looking at the numbers, and it's about 12,000 men per year in just the UK who will die of prostate cancer. But there's a very, very large number of people, perhaps 80% of 80-year-olds, who have prostate cancer. So on the one hand, yes, we want to find those people and see if we can help them, but we don't want to find the people for whom it will never be a problem. So when David Cameron says there should be a screening test, we seem to be in a difficult position then.
Let's be clear. Prostate cancer accounts for only 4% of all male deaths in a year. In other words, that 12,000 is actually only 4% of all the reasons that a man can die of. So if you put in context, men will die of something else at 96% of the time. So if you look at it that way, and you say, well, what is it exactly that you wish to do with this mortality? We have to be clear that you may detect prostate cancer early for some men and treat it and therefore stop them from dying of prostate cancer, but they will die of something else. So the question really is, if you put all the money in investment into just prostate cancer screening and testing for that 12,000, what will you not do for the 96% of men who may die of many things, particularly heart disease, strokes, things of that nature? How much harm could focusing on just this one thing do? When actually, I know even in urology, we have bladder cancer and kidney cancer, which has a much higher incidence to mortality ratio than prostate cancer does. So, yes, we do have men who die of prostate cancer, but the peak age of death is actually 80s and 90s. In other words, the men who are dying of prostate cancer are actually men in their late 80s and 90s who are probably going to have many other illnesses as well. And if you invest to try and reduce that rate, what will you have to take the money away from?
What would you advocate then for someone who's in their 50s and they've seen David Cameron's statements in the press this week, and they've perhaps heard of some friends who themselves have been diagnosed with prostate cancer? What would be your advice to them?
I think that we do have a test which can be used to start the question and the journey. And therefore, if they are concerned or they have reason to be concerned, then by all means go and have a chat with the GP and get a test. But what needs to happen is there needs to be a understanding that prostate cancer by and large is not a lethal disease. And therefore, even if that diagnosis is made, it does not mean it needs treatment. A lot of the problem is that, naturally someone would equate the word cancer with a disaster, as in, I'm going to die. And that is just not the case with the vast majority of prostate cancer. So, by all means, if there is a concern or a question about prostate cancer, have a chat with your GP. And once you understand the risk balance, then actually go for that test. But understand that that's just the first start of a process. And at the end of it, it may be that nothing needs to be done.
Very insightful. Vincent Yanapragasam there. And if you'd like to find out a bit more about prostate cancer, we actually made a detailed programme episode earlier this year on this very topic, which included information on screening, diagnosis and management. And we've made a shortcut link directly to that programme to help you get to it quickly. It's at nakedscientist.com/prostate cancer. Well, into space now, and scientists analysing samples brought back to Earth last year by NASA's OSIRIS-REx mission to the asteroid Bennu have confirmed the presence of DNA and RNA genetic letters, as well as a host of important amino acids, which are the building blocks of proteins. Planetary scientist Sarah Russell, who's at the Natural History Museum, is one of the team studying these samples. Based on what they're discovering, she strongly suspects that bodies like Bennu, replete with cocktails of important life-linked organic molecules, might well have been delivering those chemicals across the early solar system and are therefore potentially linked to how life first got started here on Earth.
This is a mission called OSIRIS-REx, which is a NASA mission that went to visit an asteroid called Bennu. It launched in 2016. Then it spent a couple of years getting data on the whole asteroid, which was a 500-meter asteroid in near-Earth space. And then at the end of the mission, it collected a piece of the surface of the asteroid and brought it back to Earth. It returned to Earth in September 2023, and we've been looking at this asteroid in our labs ever since.
You've actually got some, haven't you, in the Natural History Museum?
Yes, we do. So I'm a member of the science team, which meant that we got about a teaspoonful of it. And it's like a teaspoon of tiny kind of grains, like sugar-sized grains. And we've been analysing it bit by bit.
How do you actually analyse that? What sorts of questions are you asking? And what is the process by which you look at something like that?
The big aim of the mission is to learn about the origins of our solar system, because we think that asteroids like Bennu formed in the very earliest times in our solar system. And then asteroids like that could have been impacting the Earth throughout its whole history, and so could potentially bring ingredients to the Earth as well. And the way that we look at it in the museum, I'm on the mineralogy team, so we have been looking at it in our electron microscopes and using things like X-ray diffraction to look at what minerals are there and what they can tell us about the history of the asteroid, how the asteroid first formed from a dusty disk of dust and gas, and then what its history has been since then. So we think that it's accreted with lots of ice, which melted and then formed pods of water inside the asteroid itself.
Would it have been warm enough to have liquid water?
Yeah, so when it accreted, it would have been probably in the outer solar system and very cold, but it contained radioactive isotopes that warmed it up, probably just to room temperature, and so that was enough for the ice to melt and form water.
You can see that. You can see there would have been water in there.
We absolutely can see there would have been water there, because we see minerals like salt, like table salt, sodium chloride, which are in the rock, and they formed when the water evaporated away and left it behind. It looks a lot like the minerals that we see in evaporative lake deposits on Earth.
What has turned up so far? As you've gone through this analysis, what are you finding?
We're finding that Bennu was full of water, but it's also full of organic material. And so the organics team have done lots of work, and they found this whole zoo of organic molecules in there, including all 5 of the nuclear bases that are used in human biology, in all biology.
They're the DNA and RNA letters, then?
Yes, exactly. The building blocks of DNA and RNA are inside the meteorite, and so are several amino acids that are essential for life.
Where did they come from?
We think in the very earliest part of the solar system, there would have been simple organic molecules, formaldehyde, methane, just made up of a few atoms. But then in the asteroid itself, maybe in these briny pods of water, these could have reacted with each other to make more and more complex organic molecules. So it would have been just this fantastic environment for producing new organic material.
And the new paper that's just out this week, what does that add to the picture?
This is a real deep dive into this organic story. And what they found is an additional amino acid, tryptophan. And this is another one of these amino acids that are essential to life. It's quite a complicated amino acid. And we're really excited to see this, because this is not something that we've seen in any extraterrestrial materials before. We don't see it in meteorites in our meteorite collection. And the reason for that is probably that it's such a delicate molecule that it just doesn't survive crashing through the Earth's atmosphere and landing on the ground. And so this kind of tells us that it's really important to have space missions like this that can bring back a pristine, uncontaminated sample, bring it back to Earth carefully, and then we can look at it in our labs without it getting contaminated.
Given that things like this would have been raining down on the early Earth probably 4 billion years ago or so, what role might this have played in seeding the planet with some important molecules? Or if they're quite easy to cook up, did we not just have all these molecules here already? Probably. I mean, where do you stand on that?
This is kind of really at the forefront of understanding the origin of life. I think that the results from Bennu really point towards asteroidal material being really important to, as you say, kind of rain down on the Earth and provide all of these ingredients that would have helped to trigger life to start on the planet's surface, not just of the Earth, but also Mars, and maybe also the icy moons around the giant planets as well. So to me, what it's saying is that maybe asteroids particularly are good at being able to make these organic things, but asteroids like Bennu, and maybe its cousin comets as well, would have been widespread throughout the solar system. And so these things would not have been uncommon raining down on everywhere in the solar system.
It's so exciting, isn't it? That was Sarah Russell at the Natural History Museum.
The Naked Scientists podcast is produced in association with Spitfire, cost-effective voice, internet and IP engineering services for UK businesses. Find out how Spitfire can empower your company at spitfire.co.uk.
Music in the programme is sponsored by Epidemic Sound, perfect music for audio and video productions.
This is the Naked Scientist podcast with me, Chris Smith. Still to come, a new genetic analysis answers the questions of where domestic cats came from and when. But first, researchers believe that thousands of earthquakes near the Greek island of Santorini earlier this year were triggered by molten rock pumping through an underground channel. Stephen Hicks, who led the research at University College London, believes combining physics and machine learning could help to forecast future seismic activity.
Earlier this year, in February, there was a very active sequence of earthquakes around some of the islands in Greece. So these are particularly the islands of Santorini and Amorgos. There were hundreds to thousands of earthquakes, many of which caused strong enough shaking to be felt. So some of the local schools were closed, some tourists were evacuated from the island. So there was a very heightened sense of unrest. And so the key question was this sign of a impending larger earthquake, or could it be resulting in a volcanic eruption, which of course this tectonically active region has had both large earthquakes and large volcanic eruptions in the past. So as to really understand what was causing that very active sequence of earthquakes that's now died down, thankfully.
Indeed. So how did you explore that then? Is this sort of a natural experiment that leads you to be able to study it by virtue of the fact that it's happening in the first place?
Yeah, so when we have those many thousands of earthquakes, that naturally gives us a lot of data to work with. And so what we did was actually to use the pattern of those earthquakes in the crust, how those earthquakes are distributed, and to use virtual sensors of stress almost. So every earthquake that happens in Earth's crust is a response to some sort of stress. So it could be sort of faults moving, it could be some sort of melt channel moving through the crust. And so we can use that cluster of earthquakes to be able to understand what is the cause of those. We applied a new method to be able to sort of image that source. And so that could only really be done with modern artificial intelligence methods. So traditionally in our field of seismology and earthquake science, it's been a very laborious process to really try and pick the seismic arrivals to locate those earthquakes. But now with artificial intelligence methods, we can do this very, very quickly. And that means we can detect much smaller earthquakes, and we detect therefore many, many orders of magnitude more earthquakes. So we now detect tens of thousands of earthquakes, whereas before with old traditional methods, just hundreds of them.
And would this be by using seismometers, effectively vibration sensors on the ground surface? Is that what you're doing? You've got a network of those and you can see where the waves are when they're arriving and compare?
Yeah, exactly. Most of the earthquakes that happened near Santorini in February happened under the ocean. And so you then need sort of a way to sense what's going on, because we can't really see what's happening at the ocean floor. So we can use those earthquakes, which create seismic waves, sort of ground vibrations, which travel all through the crust. And those vibrations are detected on seismometers, very sensitive listening devices installed all around the Greek islands. And we can sort of use a triangulation method to locate those earthquakes to very, very high precision. We know where they are in the crust within sort of tens of meters. And so with that seismic data, those sort of squiggles that come in on those seismometers, we can detect all those earthquakes and locate them very, very quickly.
And because there were hundreds to thousands of them happening, you got loads and loads of data points over time. So you can sort of build up a profile of how the earthquake and the system of earthquakes is evolving then.
We detected in total about 25,000 earthquakes just in February alone. There were hundreds per hour at times, so very, very intense sequence of earthquakes. And what we've done is created a sort of underground map of where these earthquakes were, essentially. And we found something very peculiar about this particular sequence of earthquakes. The earthquakes did not remain in one place. The earthquakes went sort of back and forth. They ping-ponged to the east, then back to the west towards Santorini, went back to the east again towards the island of Amorgos, back to Santorini. And so our results shed light on what's causing this back and forth motion. And that relates to this sort of escape of melt or molten rock or magma in Earth's crust, which has sort of escaped from a reservoir of that melt and travelled horizontally through the crust.
Was the molten material moving causing the earthquakes? Or did some earthquakes cause the molten material to move and then perhaps set this in train? So which came first? It's sort of chicken or egg, isn't it?
Imagine sticking a knife horizontally through some bread, a loaf of bread, right? So you're putting that knife with the blade pointed down, sticking it horizontally into this loaf. So the knife itself is sort of oriented vertically. So this is like a sheet of melt, what we call a dike. And so it's pushing horizontally through the crust of the earth, the crust of the bread. And as you put that knife through, it creates fractures. So the ground, the crust around that melt has to break to accommodate to allow that melt to flow. And so it's that breaking of the crust due to the melt moving that creates the earthquakes. And those are what we measure at the surface. And there were 25,000 of those earthquakes.
What do we take away from this then? Is this not just unique to that geology of that bit of the Mediterranean, or is this generalizable?
Distribution of earthquakes is really interesting because it tells us something about the pressure of the melt in the crust. Is it highly pressurized or is it weakly pressurized? And that really is important because it might determine whether that melt can ascend vertically to the surface and then erupt in a potentially devastating volcanic eruption. And of course, the island of Santorini had one of the Earth's largest volcanic eruptions thousands of years ago. So it's really important, not just for this particular region, but we think this effect of back and forth earthquakes might happen in these melt intrusions in other places on the Earth, such as Iceland, which is very volcanically active as well.
It really is amazing the impact that AI is having on all sectors of science, isn't it? That's Stephen Hicks. He's at University College London, and there he has a way possibly to make earthquake and volcano predictions that little bit more tractable. Well, back into the past now, and a team of scientists have discovered that our much-loved moggies may be a far more recent arrival in Europe than we previously thought. The research, which has been published in Science, has used DNA sequences to suss out that cats probably came from North Africa around 2,000 to 3,000 years ago, and ancient Egypt, well known for its adoration of cats of course, was probably where it happened. Jonathan Lossus is a professor of biology at Washington University in St. Louis, and he's written a perspective on the piece. He's also the author of The Cat's Meow, How Cats Evolved from the Savannah to Your Sofa.
We know that cats were domesticated by about 3,500 years ago in Egypt because we have paintings on tomb walls and sculptures showing cats in a clearly domesticated context. Cats wearing collars around their necks, eating from dishes underneath a table, sitting in people's laps, and so on. So certainly they were domesticated by then, and some people think that's when it happened, 3,500 years ago in Egypt. But there's also some evidence that suggests that perhaps it happened a bit earlier in the region around Turkey, perhaps as much as 10,000 years ago, and perhaps they actually moved from there into Europe maybe as much as 6,000 years ago, when the first agriculturalists moved from that area to Europe. So there was a debate, and they were trying to figure out which idea is correct.
What have cats actually been domesticated from?
Well, there is a species that lives in northern Africa and the Middle East called the Near Eastern wildcat. It's important to know that wildcat is the name of a particular species. It is not just referring to any wild cat. So this species occurs across northern Africa into the Middle East and into that area of southwestern Asia. If you saw a Near Eastern wildcat, you would think it's a very cool looking domestic cat, but you wouldn't think it was anything special because they really are quite similar to domestic cats.
Is the behaviour the same? And what do we think the mechanism of domestication was? For dogs, for instance, we think it was us beginning to gather into groups, that we would have had food, we would have had warmth, and that perhaps lured in animals with a predisposition to be more friendly, and that then led to them domesticating. Do we think a similar sort of thing happened with cats, or is it a different story?
The prevailing idea is very much the same, that agriculture first began about 10,000 years ago in the region we now call the Middle East. And when that happened, people grew as many crops as they could, and they stored the extra crops for lean times. And one can imagine a big granary full of grain would attract many rodents. And in turn, those wildcats that were willing to tolerate being around people got an extra bonanza of food to eat. And in turn, people saw that the cats were being useful, and so they probably were nice to them. And again, the boldest of the cats would come into huts where it was warm and dry. And so in that way, cats just took advantage of what we were making available to them and started associating with us. And that's very similar to the idea of what happened with dogs.
And hence it's logical to think, well, agriculture stems from about 10,000 years ago, therefore cats probably do too.
Exactly.
So how has that been turned around, or what do the new insights suggest from the new analysis then?
The researchers did two things. First, they compared the DNA of domestic cats to that of the wildcat across its range. And what they found was that domestic cats are most closely related to wildcats from North Africa, as opposed from the Middle East or Turkey. So that suggests domestic cats were domesticated in North Africa. But that was only by looking at living animals today. They then got the DNA from these archaeological sites from a few centuries ago to 10,000 years ago. And what they were looking for was DNA evidence that those ancient specimens were domestic cats, not wild cats. And what they found was that until about 2,000 years ago, there was no domestic cat DNA anywhere in Europe or in Turkey. And then 2,000 years ago to the present, the domestic cat DNA shows up. And so that suggests that domestic cats certainly didn't get to the region of Turkey or Europe before about 2,000 years ago.
And the archaeological remains we've got from way before that then, going back to 5,000-6,000 plus years ago, are those not domestic cats then? They're cat-like creatures. They're perhaps wild cat creatures, but they're not what we would call a domesticated cat.
Correct. The evidence suggests that the cats that occurred in Turkey or in Europe were probably wild cats. They were probably actually the European wild cat.
If they came out of North Africa then, why did they do that 2,000 years ago? What was going on there that drove that?
We think the cats got to Europe probably closer to 3,000 years ago because there are paintings and other representations of cats in Europe from about 3,000 years ago. The discrepancy probably results from that we don't have many ancient cat specimens from Europe from 3,000 years ago. So it probably actually was closer to 3,000 than 2,000 years ago. And the reason that matters is that if the cat was domesticated in Egypt 3,500 years ago, it might explain why that's when you start seeing cats getting into Europe. Why did they spread? One of two things. Probably they were valued as rodent control officers, and so people smuggled them out of Egypt because they were useful, certainly useful on ships. The sailors wanted cats on board. And in addition, the cats may have just jumped on ships on their own and, been responsible for their spread. So that's probably why the spread to Europe occurred only starting then, because they weren't domesticated before then.
Jonathan Lossus giving us pause for thought on where our household moggies originated and when. Looks like we've got the ancient Egyptians to thank. Well, that's it for today. Do join us on Tuesday, though, when Titans of Science returns. And in the hot seat will be melanoma specialist and Australian of the Year, Georgina Long. She's a pioneer of immunotherapy, and she's actually curing an increasing proportion of the people that she's treating these days. We will hear how. Before we go, though, an appeal to you, our loyal listeners, to please support this programme. If you enjoy what we do and you can help, we do need to meet our running costs and we rely very heavily on donations to do that. So do please consider signing up either on a one-time or regular basis. We've made it really easy to support the show. You just go to nakedscientist.com/donate. And indeed, a very big thank you to everyone who continues to do that. We are genuinely very grateful. The Naked Scientist is also generously supported by Rolls-Royce. I'm Chris Smith. Thanks for listening. And until next time, goodbye.